Hello, today we're doing forces and Newton's laws. Okay, so I hope you find this interesting. So what is a force? Um, we can, they have definitions in places. We'll define it using Newton's laws. So, accelerates, changes object's velocity. As in like the equation, Newton's second law, F equals ma. You can use this to derive the first law. If F is 0, then A equals 0. So acceleration equals 0. Since acceleration is the change in velocity with respect to time, velocity is a constant, and that's Newton's first law, if F equals 0. And then there's an argument I found somewhere that is a good way to remember the third law. So, say two objects. One object exerts a force. You can think of this as its own object. And, well, first we need the concept of an external force. External force. A force from outside. In object. So you can think of this system as one object. And since there's no external force, the velocity has to be constant. If the velocity is constant and there's a force this way, there has to be a force this way as well. And they can't be on the same object, or else, by that logic, nothing in the universe would ever accelerate. And so that's how you get the third law, basically. If this object is pushing this object has to be pushing with an equal force to keep the sort of total velocity of the system constant from the second law. That's not something. I'll leave a link in the description if I can find where that came from. But so now we have the idea of so obviously if you're on Earth, you have a force downward. If you're on the ground though, then there's going to be a force upward. By Newton's well, you're not accelerating, so there has to be an equal force upward, and we call this a normal force. It's normal or perpendicular to the ground. And it's good to know that, because otherwise, unless you're skydiving, you're probably experiencing some normal force. So, what else? We have friction. So static friction prevents movement. And then we have a formula. F static would be less than or equal to something called the coefficient of static friction times the normal force. This is important because it means that the heavier something is, the more static friction it might have. And that's like an interesting sort of way of thinking about things. And then we have kinetic friction. Between like an object and the ground. Either way, the friction would be between two surfaces. So kinetic friction slows down object that is already moving. It's another force. So force of kinetic friction equals the coefficient of kinetic friction times the normal force. And we have this normal force term again here. That's important. And you can use these to solve incline problems, which I'm not going to go into. There's trigonometry, so you would want the you have a force downward, and then you have similar triangles, and then you can use that to find angles and components, and use that to find normal force. The force this way, the force this way. And then because of this, there's a normal force this way, and that gives you the friction. But we're not going to go into that. That's all trigonometry. That's the most confusing part here. Now I guess that's pretty much it. I'm just going over everything that these articles went over. We'll go over tension, I guess. Tension. So like stuff from ropes, basically. So if you have like I don't even know. It's important. You can like hold like a pendulum or something, and it's usually in the direction of the rope, and it's it's pretty simple, I guess. Okay. We'll get into more advanced stuff later, I guess. This is like the fundamental stuff. Have a good day.